Okay, so this example, it should be pretty simple. I'd like to show that the span of 1, 0 is a subset of span of 1, 0 and 0, 1. So let's see. The span of 1, 0 is basically the set of A times 1, 0, where my A is a real number. So basically, this is the set of all vectors of the form A and 0, where my A is a real number. Okay. So let's now take a look at the right hand side. I have here the span of 1, 0 and 0, 1. So that's going to be the set of all vectors that can be written as A times 1, 0 plus B times 0, 1, where my A and B are real numbers. Okay, so this guy is the set of all vectors where, if it is all vectors of the form A and B, where A and B are real numbers. And it's pretty to see that my left hand side is smaller than my right hand side. Well, on the left hand side, I need my second coordinate, I need the bottom coordinate to be 0. Whereas on the right hand side, both coordinate can be anything, A and B can be any real number, 0 included. So that's kind of why the right hand side contains the left hand side. Another way that we can look at this is that we can look at it. We can look at the geometric interpretation of it. My left hand side, the span of 1, 0, 1, 0 is basically this vector. So the span of this vector, I use the wrong color. The span of 1, 0 is gonna be just this line. It's gonna be the x-axis that we have here. Now then, how about the right hand side? The right hand side, the span of 1, 0, the same guy, and 0, 1. These two vectors basically span the entire plane. So, and obviously the entire plane contains the line. So that's kind of why the span of 1, 0 is a subset. Well, it's actually a subspace because both of these guys are vector space. So the span of 1, 0 is a subset of the span of 1, 0 and 0, 1. Okay. Let's take a look at my next example here. I'd like to show that 2, 3 it belongs to the span of 1, 0 and 0, 1. And this is pretty simple. And that's because 2, 3, this can be written as 2 times 1, 0 plus 3 times 0, 1. So it's a linear combination of 1, 0 and 0, 1. So automatically it belongs to the span of 1, 0 and 0, 1. Okay. Let's look at my part C here. I'd like to show that the span of 1, 0 and 0, 1 is equal to the span of 1, 0, 0, 1, and 2 and 3. So let's kind of take a look here. The span of 1, 0 and 0, 1, once again, this is going to be A times 1, 0 plus B times 0, 1, where my A and B are any real number. So it's the set of all vectors of the form A and B, where A and B are just a real number. How about my right hand side? My right hand side, this is the set of all vectors of the form A and 1, 0 plus B of 0, 1 plus C of 2, 3, where my ABC can be any real number. So this is the set of all vectors of the form, let's see, A plus 2C and B plus 3C, where A, B, and C are once again any real number. Now then, notice how on the right hand side, my A and my B, it can actually be already any real number. For any real number out there, it can be my A, it can be my B, including A plus 2C for whatever real number C there is. And also my B can be any real number, so it can take on the value B plus 3C. So in other words, my right hand side is not any bigger than my left hand side, because my left hand side, the A and B here, it can already be any real number. So these two guys are the same thing. Geometrically speaking, once again, my span of 1, 0 and 0, 1, they are basically just the entire real space. So it's the entire R2 up here. Now then, even if I add another vector 2 and 3 here, so even when I add another vector 2, 3, if I span these three guys, all the linear combination of these three guys is not gonna get any bigger because this guy also it's just another vector in the plane. So this guy, it generates once again just the same set, just this plane, just the same plane that we have before. Oops. So one thing we see from here is that whenever we have a span of something, if we keep showing more and more things into this list here, my space should typically get bigger, and that's kind of what we see from part A here. If I begin with 1, 0, when I throw in more vectors, 0, 1, when I throw more stuff into this generator set, when I throw more stuff into the stuff here, it should generate a bigger vector space. However, when the stuff that I throw in this case, the 2, 3 here, is already a linear combination of 1, 0, and 0, 1, my vector space is actually not gonna get any bigger. If the new guy, let me use new color here. If the new guy is actually just a recycled stuff, it's actually just a linear combination of the old vectors, then the span, including this purple guy, is actually not gonna get any bigger than what it has before. We will touch on this concept again when we talk about linear independence in the next lecture.